It's a good follow-up talking about systems that treat water, considering I'm working with an organism that produces toxins that most drinking water systems do not treat. So this is an emerging threat in the sense that these large cyanobacterial blooms produce a variety of toxins that most drinking water systems do not manage at all. And so in the year 2014, the city of Toledo was actually issued a ban on all municipal water. They were told, don't drink it, don't let your pets drink it, don't try to filter it, don't try to boil it, and don't even bathe with it, because some of these toxins are actually contact sensitive to humans. And when the EPA looked at freshwater systems across the US, we found that a vast majority of these, well, not necessarily majority, but an alarming number, have at least one or multiple cyanobacterial toxins in them at any given time. And these are systems that we use for drinking water, for agricultural purposes, for livestock, etc. And climate change projections actually put the increase in water temperatures right in the sweet spot for a lot of these cyanobacteria. So we're concerned with what is causing these cyanobacteria to proliferate to the point where you can actually see these blooms from space. And more importantly, what is causing these blooms to become toxic? Because the most complicated thing about many of these cyanobacteria are that not all of them are capable of producing the toxin. So the ultimate question we have is what makes them not only toxic, but what makes them produce the toxin? Because just because they have the genetic potential to make the toxin doesn't mean that they're always going to be toxic. So our group has started a multifaceted microbial and molecular approach to basically get as much data as we can on these blooms from both an ecosystem and a genetic perspective. So we want to know what genes they have, toxin genes, non-toxic related genes, and how they work within that organism to either make it toxic or non-toxic, and what factors contribute to the proliferation of these large blooms. And ultimately what we're working towards is an integrative system that's going to be an online database in which all of this data is available in a user-friendly, searchable manner. So we don't expect you to have to go through all the genetic sequences yourself. We want you to be able to put in your own query about, okay, how does nitrogen levels impact toxicity in certain strains of cyanobacteria? And this system will give you the result instead. So you don't have to get the sequences, you don't have to do all the assembly and all the molecular bioinformatics, you can just get an answer to the question you have. So we're trying to do the front end work to get the genetic information, pair it with environmental data through our partners with NOAA GLERL and Seiler and the University of Michigan, and then generate this data into a user-friendly informatics system that any end user could then query with their own particular question. So some interesting things we've already found is within this genetic variation within one species, right, we find that different strains of that species, so within a bloom we find multiple almost sub-strains of one species, and they all have different genes. So they all have different genetic potential to do things. All right. And not only do we find that those genes actually occur in a bloom, this was from Lake Erie, but many of those genes are actually highly expressed. So these are genes that we didn't know about until we sequenced them ourselves, but they're being used. So what impact do those unique genes have on the bloom itself and on things like toxicity and how toxic or non-toxic a strain or a bloom is? Right. So then, back to the database. Once we get that information, once we understand what genes are there, we can start pairing those genes with all of the collected environmental data and then feed that into predictive models. So instead of having to wait until the toxin's in the water system and then say, oh wait, you can't drink it, you can't use it, we can then start to work towards predicting when blooms could become toxic and when we should be more vigilant of looking within our water systems for the toxins that are there. All right. And so that's where we are at this point, where we actually have sequenced different strains from the lake. We have some sequences in our lab itself. We're generating more and more sequences, and we're beginning to build this database and work on getting that information and getting that database publicly available so that more researchers can not only look at the data we have, but add their own data to the system and expand our knowledge outside of the Great Lakes region. Thank you.